Sure, Gautam. So today we'll be working on a system design question, and the question that I do have for you is a Bloom filter. So the idea is to understand and then try to code out a sample Bloom filter, the core components of it, and take it from there. So Bloom filter is a small component filter which just tells you the presence of something that might be there, which says that there's a component, the specific term, there's a specific thing that you're searching for. This might be there, or it says that something related to this is not there for sure. And when it
Yeah,
says that something might be there, it means that something related to it might be possible there as well, but not necessarily. So let's take an example of something as when we do search for the usernames, when we're trying to create
mm,
out an account, right? As soon as we try to search in out, like this guy, let's say username 123, and the system says that this is not there, or it says that this one is there, or some is there. So telling it that this value is absolutely not there for sure is a Bloom filter. So which what you can do is that you can save yourself from the query or the DB call, and then can make absolute decisions on top of it. So that's the basic idea that we have for a Bloom filter. And
yeah. So I would like to add one more thing. Like whenever you're dealing with data, the thing is you don't actually store it in one database. It might be stored in like hundreds of database. Like it might be sharded. It might be like there might be some process which involves splitting the data into multiple out there. So in the essence of Bloom filter is whenever you you're looking for a data, like for example, the username is Gautam. The thing is, it might it might run through some kind of function. It will generate a hash or something. And what it does is you actually try to ask the database, is there a possibility that this hash or this person might be there? If the database says that no, it's not there, you actually save a lot of cost by just not even touching that database. So there might be some databases which might like there is a possibility that this person might be there. And because of that, you might end up having to search for it. But the other point is that you would have anyway would have searched for it. So you are actually eliminating the databases which you don't have to search.
that's true. Yeah,
So yeah, uh, because you're not searching, you're actually optimizing for like a lot of costs. You save a lot of costs behind that.
yep, yeah. Okay. Say that you
Mm.
what you have done in your code is that you have taken a hash function, right?
Yeah.
And the collision, and consider this returns just numbers. Okay, it makes a
Okay.
hash out of it, but the hash is in form of a number. Got it?
Yeah.
So with that lies the possibility that since this is a hash function, this will be having less collision.
Okay.
Okay. uh that being, it will still, since it's a hash function and we are working with a finite machine, this will be within limits.
Okay.
Do you agree with that?
Yeah.
Yeah. So now with line number 83, you do say that there's a possibility that I'm using a hash function and this is working within a limit, and let's say that we are not using a very big hash function. This one holds
Mm.
a limit of assuming it is starting from 0 to, let's say, 1,000. Is that
Okay.
convincible?
No.
Let's
See.
consider we have a very small function which is having a limit within 0 to 1,000.
Okay. I can't actually
Okay.
see. There is a case where there are 1,000 entities which might be different. But then 1001, the this is better, but this still the limiting factor is that it is the how big of a
Exactly,
uh,
exactly. I'm putting it small so that like I will be able to make the problem less complicated.
yeah,
So let's consider you have a limit of 10 power 9. So your hash value produces a number between 0 to 10 power 9, right?
yeah,
Perfect. Now the hash function says that when I do return something as a true, there's a possibility that this might be available, but I'm not sure.
mm,
But if it's not there,
yeah,
I'm perfectly sure that this is not there, right?
yeah,
Yeah. So let's say that when you do have this very big of a limit from both of the ends, and I'll
mm,
be having a very less collision in that, I'll be having a very sparse matrix or very sparse data structure, right? So you'll
yeah,
be wasting a lot of space in it. Uh,
yeah.
do you think that you can actually save me these empty bits which are present in this to consider, let's say that I want to have a bloom filter of only size say 64 now, and within that 64 uh, I need to boil down all the values that I hold. And let me tell you how or what I was thinking till this time. So say that
Okay,
you are produced one of the number within this range with your first function that you have implemented. Okay, you get a value,
okay,
say you get a value 100 for one of the one, and then you get 1,000, and then you get like say how much this number is. Okay, and
mm,
but you are having a lot of bits which are empty. Now what you do is, since the objective of the bloom filter you're saying is that I possibly say it's true if I have it, but if I don't have it, I'm
mm,
sure I don't have it.
yeah,
Okay, so uh, I have this as a range stating that I cannot have a bloom filter size of, let's say, more than 64 bits. So what I did was I divided these guys with 64.
okay,
So now I'm having a array. Consider that this was an array, which is having a range till 10 power 9. I've reduced it to 64.
yeah,
Okay. So now all of these numbers, when they're divided with 64, I'll be having their remainder within the range of 0 till 63.
yeah,
Correct. Now, if now let me shrink down, and this is an assumption case that when I do divide these guys by 64, all of them are having same reminder. Let's say that, assuming,
okay,
okay, you have three numbers x, y, and z. When you divide it by 64, you're getting the same reminders. So when you have this 64-bit array, they will be setting a bit to 1 for all of the same, right? So let's
yeah,
say all of them are having x bit, x location where they are setting the bit true.
yeah,
So now they have bit to 1 in x position. Now x is being stated as true in the case of 100, and when 1,000 came in
mm,
picture, it made true for 1,000 as well. And let's say 100,000 million, 100 million. With this number, you can't read it. With this number as well. Okay. Once that is done, now what happens is, if I don't have this number for a moment, got it? With
mm,
these two numbers, the bit x is set to 1, means that I have something in that location, even for the big guy number, right? But when,
yeah,
so it will return true for this. But when I do return input search as A thousand is having the same reminder, like the first of the real number. Through that I obtained 1000, and then through
Mm,
64 dividing I get x again, but x
mm,
is already set to 1. In this
mm.
case it will say, yeah, I have 1000 as well, but 1000 is actually not there in my value anymore. So that's how
Yeah,
it does gives you a false positive.
yeah,
And if, but in the case of, let's say that if I was having something as 999 in this and 64, so I'll be having something of a reminder, let's say x minus 1, and my x minus 1 is 0. It says that it's true that I don't have 999 in my value. Okay,
yeah,
do you think that you can implement this small scale down, or is it too much?
yeah. I'm able to, yeah, bloom
Perfect,
filter.
which is all yours.
Okay. So one of the things that I mentioned about bloom filter is that you actually make a hash out of it. So the thing is, whenever you try to search for a data, it might be of different kind of nature. Maybe like let's take the username. Some people might have a username of 5 characters. Some people might have 7 characters. Some people might have 10 characters. You can make a username of n amount of characters. What we need to do is we have to run it through some kind of function, which will make a hash of similar length so that you can search it much faster.
Okay.
Uh, so I think there is this one class that we need, which is called hash function.
Okay. Maybe like initially, can you like list down a specific, a rough idea of the components that you have in your head, and after that maybe you can start implementing out the real ones.
Okay.
Yeah.
So so one thing is hash function.
Mm-hmm.
Uh, do I need to actually look at the data store or database?
No. So in this one, you can consider this to be like more of just a data structure development. So let's
So
keep it.
so the question I asked was because sometimes what happens is that whenever data is added, it doesn't have to be permanent. So for example, I added my username to this database. Maybe in like 5 years, you actually do a horizontal scaling, and what ends up happening is that the data from this database got migrated to another database.
Yeah.
And because my name is not there, uh, when you do an bloom filter for this, uh, you will get a positive for that.
Yes.
Maybe removing my name, what happens to that? The same, what do you call that?
So the topic that you're saying is more of like we can take it as a challenge in bloom filter when you're trying to, let's say, rescale, or when you're trying to scale it up.
Yeah.
So right now I think like we will try to concentrate more of as uh, we will take that topic if we have time, but considering more if it just as the core with the bloom filter itself, not the component that it will get connected to.
Okay.
More I mean by that is, for example, I'm doing my hash function, that search that you're saying, within the bloom filter, and not in the db for now. And the topic that you have said, we will be discussing it out, like if we can find out an answer, how do we want to increase or reduce a filter size. That makes sense.
Okay. So we don't have to count the number of occurrences and all, right? For example, if there is a data and you have some amount of occurrences for that, the minimum number of occurrences that you have to actually search for. We don't have to index and all, right?
No, no.
So I think the two components are the filter and a hash function. This would be more or less what you would need to make a basic bloom filter.
Okay. Can you like tell me each like functionality of both of those that you're thinking?
So the hash function, what its job is, that it might be a black box for the blue filter, but what happens is that the data is given to the hash function to process it. It might be MD5 or it puts out a output. It puts out an output which could be used by the the filter. The filter, what we do is we store this data. Like for example, let's say that the hash function gave me this. Okay. Now, okay, how do I explain it better?
If you want, we can take an example as
Okay, let's take an example. So there are two DBs. Okay.
well.
One of them has my name, one of them has your name, Sahil. Okay. So for me, when I pass it through the the hash function of my name, it outputs, for example, this a binary value. Okay. For you, it might not be the same. We're just assuming that there is no hash collision.
Okay, you yeah.
Okay. So right now there is only one entry. Okay. So the blue filter for this BF1 is 32-bit. Okay. And what you see is a 16-bit. Let's call it 16-bit. Okay. So
Yeah.
what I do is I add it to the new data structure. So in this data structure, what we do is for each bit that is true, I'm going to just flip it to true in the new data structure. Okay. So in that, whenever I try to find Sahil, okay, in the blue filter for the DB1, what ends up happening is that I will pass it through the filter. This will give me this value. And when I do uh, an AND of this with the DB1 Bloom filter, it will give me a different value. If the AND value is different, that means that some of those bits have changed.
Okay. So I'm simply as expecting is, for example, let's say that I give you a function and I
Mhm.
say insert Gautam. I say
Yeah,
insert Sahil. Okay. When
yeah,
I do say search query, when I do the search with Sahil, it says one true. Or let's say that
yeah,
when I do a third string without this entry, say prompt, it just simply say
yeah,
false.
yeah. See, the thing is, it might be there, but if it is saying false, it's not going to be there in the
Yes,
database.
for sure, it's not there.
Yeah. So the thing is, the basic logic for this is if it is there, it has to pass all the condition. But if it is not there, it might fail in one of those bits.
Okay.
Understood?
Yeah.
Uh, so yeah, that is the entire logic. See, we use the hash function to generate a hash, so that we can store that in the filter.
Yeah.
The filter job is whenever there is a new entity, whenever there is a new query that comes, you basically look at you make a hash out of it and you look if that hash has a probability of existing there.
Yeah, that's fair enough. So you
Yeah,
take the input, you make a hash out of it, and you just, so by the time you're doing a search, you do the hash again, and then you just try to search whether that hash exists or not. Yeah,
yeah.
that's the core lying idea. So I think we can start with that, and then we can take on the aspect of why collision is like a good thing in Bloom filter.
Is it though?
Yes, that's how it works.
Okay. I had a different opinion, but yeah, I think this is a discussion that we should have right
Yeah.
now. So let's. So I'm just right now implementing. I'm very sorry. Should I start implementing or like?
Yeah, we can. You have laid out the foundation. We can work on
Yeah.
it.
So HF5. This is a custom function that I'm making. Okay, let's talk about the structure of the hash function. So you initialize it with some kind of logic. You have to have some kind of logic, right? So we have to get the hash. This will have some kind of logic. Now, HF5 is a type of hash function.
Okay.
So you have to give all the same functions. So it's a what do you call inheritance. It's a type of hash function. So you inherit all the variables and functions from that. Okay. So for get hash, maybe I'll just make up a logic right now.
Sure. Even if you want,
Uh,
we can work with the pseudo of this. Anyway,
yeah. Okay. I think the pseudo would be pretty good.
yeah.
Now there is a new thing. There's a new class called filter. So what it takes is the type of hash function. Okay. And it also takes the new what do you call the filter, the data structure.
Yes.
So I think even the filter data structure can be abstracted, right?
Sure. Would you like to tell like how or what data structure you're thinking you'll store this thing?
So sometimes people just take bits. So I showed you a very primitive one, but
Yeah.
I take the bits and I just do an OR.
Yeah.
So whenever there is a filter data structure, the reason behind the data structure is that whenever this data structure, you have to add it to that data structure, you have to do some process. When you have to find the thing, find the occurrences of it, there is another entire process. So I think the abstraction of this data structure would be a beneficial one in this case. So I have to add one more to this requirement, data structure. So sometimes some data structure they use tree, sometimes they use map, sometimes they use bit binary operations, sometimes they use this arrays. So depends on that. So the same thing. So one of the function that you have to add is add data hash. So I have a blue filter data structure and I have to add this. Okay. So I think the blue filter data structure is also done. Uh, I think we can add, I think we can start doing more stuff to this.
Okay.
I know there is an error over here. Okay, you have the data structure. Now you have it, this thing, add data to filter.
Oh, are you making filter as the primary class that you'll be exposing for the
Yeah,
APIs? Okay. Okay. So then in that case, you can just simply keep the public API as add. That's enough.
okay.
Yeah. Yeah.
So you actually get the data.
Yeah.
So what we do is we get the hash data hash equal to self dot hash function of data.
Yeah.
Should we actually see the hash function will give you a hash, right?
Yes.
See, I think even for the hash, I should be abstracting it. What do you think? Should we abstract that also, or like
Define abstract. What do you mean?
abstraction of hash? Like hash can be of different nature, right?
Yeah.
So it could be just a number, it could be just string, it
Yeah.
could be
This
just a
is,
binary value.
yeah, this is the thing. So, my understanding with this was that you, let's say that you create a number out of it, your hash as being
Mm,
just completely a number, and that number can be a location, right?
mm,
So let's say that if you have a linear data structure, you have a very big array, and you know that with the name Gautham, I got a hash value of, let's say, 1000. So you point to the 1000th location in that array, and then you mark that bit as 1, stating that you have that value. So
So
to back to the idea that what I was thinking, and the question that you asked me, that what abstraction type I should be having with the hash. So let's say that we do consider something, it being just a number. Okay, and I have these four locations. Okay, and I do
Mm.
have Sahil. When I create
Yeah.
Sahil, it, let's say my hash functions returns me 3. Okay,
Mm.
in my linear array for simpleton, I have my linear array. I get a hash function value here as 3. I come to 3 and I mark 3 as 1, which simply says that yeah, my value is there. Now, uh, the point that you made, that abstraction of hash, can it be numbers? That is a very good way that I was thinking as well. But you do need to understand this as well, that hashes are very discrete and hashes do not have collision. So I don't think so you can like probably make a very big linear data structure out of it, because then your Bloom filter will be consuming a lot of space.
Yeah. So it's a matter of, see, the thing is, whenever there is a collision that happens, it means that the hash function that you have written uh, might not be up for it. So sometimes what happens is that, see, you can start with something very simple, like just sum up all the number and just do a modulus of 100 or something like
Yeah,
that. So that will ensure that, see, the thing is, at the end of the day, how well uh, a hash function is made is through the possibility of collision, how much percentage of collision is happening. And that is a trade-off that we should
yeah.
actually be looking forward to.
But in this one I would expect you to have a bad since, because the size of the filter, the storage that the filter is taking should be in a specific range. I don't, I cannot have like an infinite size of a Bloom filter, right? So you do need to, might want to use collision as a good thing here in your Bloom filter. So but maybe we can, like, once you're done with your implementation, I can give you that bit as a cherry on top to work upon it, and then maybe you can optimize your code. And I do see that you're writing down your code as like modularly, so I think you will not be having much of an issue when you are working on that component.
Yeah. So right now we are going with very simple hash that
Yes.
we are not going to like design it further, right?
Yeah, yeah, your call.
I think we'll just stick with a very simple hash.
Perfect. Yeah.
Okay. So add data hash from the hash function. You take it from there and then filter data structure. You actually put the hash.
Okay.
We are not going to remove the data, right?
No.
Like right now, that is not the priority.
No.
Okay.
So I just
That
expect you
is
to add values to your Bloom filter and search for it. That's it.
okay. So search is
Yes.
another component that we need to have. So in this, you do you do the same thing. You take the data hash
Yes.
and then you actually look at the search for the data, right?
Mm-hmm.
So you might be thinking like, I'm actually replicating the same code, add data hash, add a search hash and all, right? So sometimes what can happen is that you might actually be asked to add more hash functions. It might be a list of hash functions, right?
Yeah.
So that can also happen. So I was supposed to abstract this. Uh, let's let's abstract this. Okay. Uh, Simple is a type of filter. You get the same thing, and you have add and search,
Okay.
right? Like for example, I should have also, yeah, add. So there is this one where we are only taking one hash. Okay.
Yeah.
We take the hash and then we supply it to the filter data structure. And then there is another one. We take the hash and we do the data like that. And then, okay. So I think I should have written it in a fashion which would have been, what do you call it, compliant to Python 3. That would have made it much more easier.
Okay.
I think it's still possible. Maybe. Um, yeah, still possible.
Right. So this is like your base code for the Bloom filter, right?
Yeah.
Okay. Uh, Maybe if you can give us like a quick flow of running, how you're thinking, and then I can ask my doubts on top of it.
Okay. I'll just show you how this is going to work. Right. So, for example, we made a, like, we actually had an abstraction. We'll just shift all the abstractions to the top. It makes it easier. Uh, okay. So we have three things. One hash function HF5, which is going to be it contains some kind of logic. Okay. So we have the hash function equal to, it's going to be an object of HF5,
Okay.
doesn't take anything. So it's a function, right?
Yeah.
Uh, we have a new data structure for blue filter data structure.
Okay.
And we add it to simple blue filter, which has the hash function. And so I should have named it better. Okay, we created the bloom filter. Okay. So after the bloom filter is created, what we are going to do is whenever there's a query, okay. So bloom filter, do you want it to be a singleton or like let it? It
No,
doesn't make
that's
any
fine.
sense if it is just a singleton. So
And
I think this is going to be enough. Uh, Bloom filter dot add. So I added my name. Yeah. And filter dot search for prompt.
cool.
So it's doing some kind of spell check on all the
No, yeah, yeah,
variables.
that's fine. That's by me.
See, if we make a really good hash function, the Bloom filter search for prompt is going to give us false. But uh, in this case, it might come as false or it might come as true. But in our case, we are going to assume that it is going to come as false for now.
Okay.
Uh, Actually, like we're talking about how hash function is used to get the what do you call get the hash, and then we try to look at the
We just need to like
uh,
trim it down.
yeah, we can do that.
Yeah.
But in this, what we are doing is we are using another hash function. I have this doubt. Like, are we using another hash function just to
To uh,
somehow?
so we cannot like let in this case we shall not call it another hash. It's more of like we are limiting our number, so it's more of a size limiter.
Mhm.
We can consider this to be a prime number or the specific size that I consider it to be, and then each time I do get your yeah, this one. After this I add another statement to trim to size, and then I add it to my data.
Okay, we can do that. By the way, you know that a hash function's job is to be consistent for the same data.
Yes.
So if I'm telling that I'm giving you apple, it will always give me some value. Like maybe if I give it apple, if it gives me orange, every time I give it apple, it should return me orange. So that is a thing. But the thing is, for hash function, it should be one way. If I try to shove back the orange, it should not give me back apple. So
Okay.
the thing is, if I give apple and it gives me orange, now I try to provide it with orange, it might give me something else. So you can actually do it like take the hash and give it to another hash function, and it
Yeah.
will give me a separate hash, which
Yeah.
would be of our use.
Yeah. Yeah.
So
And
shall
but
I do it
this
like that?
yeah, you can say that. And this hash objective is actually just to keep it within my range, and considering that this rough sketch that I've done, the false positive returns that it does gives is actually happening because of the second function now, second hash.
Okay.
Yeah.
So in this, we are still using one data structure, right?
Yes, yes. I think like for this implementation, one data structure is good enough, because you can the value update that you're doing here, you can make one operation of another hash on top of it and then just store it at once. You don't actually need to keep a replica of that intermediate data, right? Or if you have like any
Yeah.
other solution in your head, please feel free to answer.
So I have multi-bloom filter,
Mm-hmm.
okay, which is a type of filter. And the thing is, hash function is, sorry, I want to copy this. It's a type of list.
I'm sorry, I lost you. Where are you? Yeah, got it.
Yeah. I don't know why my keyboard is sort of not agreeing with me right now.
Yeah. Computers are mean, they behave weird in front of friends.
So you consider me as a friend. That's a huge deal for me. But I did not expect you to give me such questions. So friends always
This
go easy on other friends.
this is a good one, right?
Mm.
By the way, you're writing
So
real clear code. I really love your code, man.
thank you for hash functions. I think this should do it.
Hmm? What
So
is
in this, we are passing it through multiple hash functions. So I'll just show you how this is done. Multi-filter. So let's take, I'm doing it bitwise twice, for example.
okay? Yeah.
This is just for, uh, sorry, HFI, not the structure. Sorry, I by mistake I mistook the structure as the hash function. And now the same thing.
Yeah. Capital L. Yeah.
Yeah.
Perfect.
So yeah, in this, the multi-bloom filter, what we are doing is we are supplying with multiple hashes, and there is this one data set.